Good morning. Today you're going to gather data on the probability practice lab. So Mendel, when he was doing his work, it really had a strong mathematical basis. And that's why he was able to uncover the patterns of genetics, because there were patterns, there are actual mathematical patterns. So to model that today, what you're going to do is create a setup that looks much like this one. You have your tally sheet for your data, where you're going to record how many of the flips of the coin chance of two alleles coming together will create an offspring that is homozygous dominant, or an offspring that is heterozygous, or an offspring that is homozygous recessive. Ta-da! Now, to do that, what you need to do is there's a card that you're going to create, and on the card there's going to be two crosses. The first one is going to be a homozygous dominant with a heterozygous. Those are the two parents and the alleles they possess. I set this up for a demo to do the second one so that you don't get confused. I think this one is the one that usually confuses people a little bit more. So you have a heterozygous parent and a homozygous recessive parent. So let's say, let's say that this is the mother and this is the father. So put the arrows on there. Now, to represent the mother's alleles, so in meiosis, these alleles are going to segregate from each other and go off into an egg cell, one of the alleles. So mom's possibility of what she can contribute to that egg is either a dominant allele or a recessive. It's one or the other, one or the other. So that is her contribution, the chance of either of those. Dad can give either the recessive allele or the recessive allele. So this is going to represent Dad in the cross. Now what you're going to do is you're going to take these two coins, one representing mom and one representing Dad, and the possible alleles that they could give to their egg or sperm cell that would then combine to make the zygote, the offspring. So you're going to jostle it, flip it. Okay, so now my first is homozygous recessive. And you're just going to keep taking these, flipping them, and tallying them. So try to jostle it. Okay. And you're going to do this 50 times. So once you get to the 4, then you cross-hatch for the 5. 50 times. And there is a mathematical basis to this, which is what I'm going to show you. That's my first in that category. And 50 times you're going to generate the data. Then you're going to go on to the next cross. That's all you're doing today, is generating the data. Now, once you generate your data, what I'd like you to do is reach out to 2 more people. So your sample size is going to be 50. Then you're going to get data from 2 of your friends. So now your sample size of data goes to 150. And then I want you to look at it for a pattern. And then tomorrow, we're going to talk about the pattern, which should become very evident to you. You can even make a prediction. For example, will this category even get filled with these 2 parents? Can these 2 parents have a homozygous dominant child? And then after we do that, we'll wrap up the lab tomorrow, which is going to help us to move on to something that's a little bit more exciting. Well, this is pretty good, which is human genetics. And then you're going to explore traits that you possess. And then by the end of next week, you're going to put together a pedigree showing traits in your family. And then that's a wrap. All right. Have a great day.